Hello students and welcome to our meeting. I'm your teacher Sir Jimmy Guban, and for today's lesson we'll discuss Module 1, so please listen carefully. Earth Science is a core subject taken in the first semester of grade 11. This module is designed to provide a general background for the understanding of the Earth in a planetary scale. It represents the history of the Earth through geologic time. So when we talk about Earth Science as a core subject, it means that Earth Science are composed of different branches of sciences, which are in line with the theoretical application and scientific research. Therefore, we can apply our knowledge in Earth Science in our daily living. It discusses the Earth's structure and composition, the process that occur beneath and on Earth's surface, as well as issues, concerns, and problems pertaining to Earth resources. Earth science doesn't only focus on Earth's interior and exterior structure, but also includes description, prediction, and understanding of natural phenomena, which are also connected with problems pertaining to Earth's resources. Earth is continuously evolving since it began to exist billions of years ago. You will learn from this module the various processes, internal and external, that lead the present structure and phase of the Earth. This module covers basic ideas about the natural processes. Earth was already 4.5 billion years ago. This explains that our Mother Earth is always changing. Tectonic plates drifted just like the movement of a supercontinent Pangaea, a supercontinent that existed during the Paleozoic and Mesozoic eras, before the process of plate tectonics separated each of the component continents into their current configuration. So it is also stated that we must learn the various processes, internal or external processes, or Earth's, because Earth's surface is the only habitat available to human race. Understanding the processes by which that habitat has been created and continually altered is important to determine the causes of environment degradation, to restore what is degraded, and to guide policy decisions towards a sustainable Earth surface. Earth science is the name for all the sciences that collectively seek to understand Earth and its neighbors in space, includes geology, oceanography, meteorology, and astronomy. So why Earth science has so many branches? This explains that the Earth is so large and science is so complex. Kahit nga yung layers of Earth natin ay nanatiling theory pa rin, dahil nga wala pang taong nakakapunta sa sentro ng mundo. At katulad din ng pag-aaral ng tao sa Earth's ocean, nananatili pa rin 95% ang hindi pa natutuklasan. Kaya kailangan talaga ng Earth science ang mga branches na ito. And since all of the branches are connected together, specialists work together to answer complicated questions about Earth. So let us now discuss the different branches of Earth science. Geology literally means a study of Earth. Geology is often divided into two broad areas. Historical geology aims to understand the origin of Earth and its development through its history. Physical geology seeks to understand the processes that operate beneath and upon the Earth's surface. This explains that in order to completely investigate the changes happening in our planet, the past and the present event must be studied. That is why geology are divided into two broad areas. In addition, historical geology is the study of analyzing Earth's past by investigating rocks and the information found in them. Physical geology focuses more on the present day planet, while historical geology investigates the planet's past. Oceanography includes the study of the composition and movements of seawater, as well as coastal processes, seafloor topography, and marine life. Earth is often called the blue planet. More than 70% Earth's surface is covered by water. So, how does oceanography help us? Physical oceanography, for example, is a career protecting the sea life from extreme weather and its impacts. Studying waves, currents, coastal erosion, and the way light and sound travel through water can help physical oceanographers understand the way weather and the climate impact marine life. Meteorology is the study of the atmosphere and the processes that produces weather and climate, acted on by the combined effects of Earth's motion and solar energy. The atmosphere reacts by producing weather, which in turn creates the global climates. So this explains that meteorology is important because of the impact of air conditions on life. First of all, weather forecasting has a vital role in urban administration. Cities preparing extreme weather conditions, such as tornadoes, snowstorms, in order to prevent disasters. For example, the Philippine Atmospheric Geophysical and Astronomical Service Administration, or the PAGASA, is the agency responsible for assessing and forecasting weather, flood, and other conditions essential to the safety and welfare of the people. So last week in your Google Classroom activity, I asked you about what is the relevance of studying earth science and its branches in preparation for a disaster. And you did it all the best answers. So for that, congratulations class. Astronomy deals with the understanding of Earth requires that we relate our planet to the larger universe because Earth is related to all of the other objects in space. So, by studying the cosmos or our universe beyond our own planet, we can understand where we came from, where we are going, and how physics works under conditions which are impossible to create to recreate on Earth. On a more pressing level, astronomy helps us study how to prolong the survival of our species. For example, it is critical to the studied the sun's influence on Earth's climate and how it will affect weather, water levels, etc. So in your module 1, we will discuss uniqueness of Earth and the four major subsystems or the Earth systems. So at the end of this module, you can describe the characteristics of Earth that are necessary to support life. Explain that the Earth consists of four subsystems across whose boundaries matter and energy flow. So our home planet is the third planet from the Sun, and the only place we know so far that inhabited by living things. While Earth is the only fifth largest planet in the solar systems, it is the only world in our solar system with liquid water on the surface, just slightly larger than nearby Venus. Earth is the biggest of the four planets closest to the Sun, all of which are made of rock and metal. So what makes Earth different from other planets in the solar system? There is life on Earth. That is the best answer. Several factors necessary to support and sustain life are found on Earth. One of the factors that can sustain life is water, which in its liquid form is vital for DNA and proteins to swim around and interact with the environment to carry out reactions needed for life. So, in this statement, it simply pertains to biological rules of water. Water is directly involved in many chemical reactions to build and break down important components of the cell. Photosynthesis is the process in plants that creates sugars for all life forms. Requires water also. Water also participates in building larger molecules in cells. Molecules like DNA and proteins are made of repetitive units of smaller molecules. Putting these small molecules together occurs through a reaction that produces water. Conversely, water is required for the reverse reaction that breaks down these molecules, allowing cells to obtain nutrients or repurpose pieces of big molecules. Other planets, because of their distance from the Sun, have temperatures that do not allow water to be in liquid form. Hence, water that remains in solid form may not be able to dissolve many substances needed for a chemical reaction that makes life possible. So, in this statement, nothing is more important to us on Earth than the Sun. Without the Sun's heat and light, the Earth would be a lifeless ball of ice coated rock. The Sun warms our seas, stirs our atmosphere, generates our weather patterns, and gives energy to the growing green plants that provide the food and oxygen for life on Earth. The distance between the Sun and the Earth is very important, mainly because of the Sun's heat. If we were too close, the whole Earth would fry quickly, like planet Mercury. If we were too far away, like Pluto, we would be freezing. In fact, astronomers often focus on habitable zones of stars, also called the Goldilocks zone, orbits of the planets that are neither too hot nor too cold for life to exist, to search for extraterrestrial life. So, indeed, the Goldilocks zone, also known as habitable zone, is the orbital region around the star in which an Earth-like planet can possess liquid water on its surface and possibly support life. In our image is the representation of Kepler 90 system planets with various sizes. This system of planets are candidates for a planet that supports life and also located at the habitable zones of stars. Earth is unique. It is a living planet and where energy flows continuously within its system. Most of the living processes on Earth depend on the light energy from its star, the Sun, which is considered to be the ultimate source of energy. So, for example, as sunlight enters the Earth system, one of the two different things can happen. It can either be absorbed or reflected. Once energy has been absorbed by the Earth system, it is transformed and transferred. The sun is the ultimate source of energy. Every morning, the sun rises, bringing light and heat to the earth, and every evening it sets. Plants convert light energy from the sun into chemical energy as food by the process of photosynthesis. Animals eat plants and use that same chemical energy for all their activities. So within Earth, energy also circulates to be made available and accessible to all life forms. The different forms of energy also allows for recycling of molecules and nutrients needed for life. So for example, through the process of photosynthesis, carbon dioxide is pulled from the air to produce food made from carbon for plant growth. Carbon moves from plants to animals. Through food chains, the carbon that is in plants moves to the animals that eat them. Animals that eat other animals get the carbon from their food too.